In part 4 of the Unit 6 notes, we are going to be covering formulas for binary ionic compounds. When writing out a formula for an ionic compound, you must consider how many of each ion are required in order to create a stable formula unit. Magnesium must give up 2 valence electrons in order to reach a noble gas configuration. Bromine has 7 valence electrons and is only able to receive 1 before it reaches a stable octet. In order for these 2 elements to bond, 1 magnesium and 2 bromines are required. If you consider the Lewis dot diagram which is shown here, you can see each of magnesium's 2 electrons. One is going to go to the bromine on the left, and one will go to the one on the right. This results in a positive 2 and 2 negative 1 ions which are attracted to one another. So the formula for magnesium and bromine would be MgBr2. Instead of drawing a Lewis dot diagram every time you want to create a formula, you could use the charge of each ion. By crossing the charge down to the opposing atom's subscript, you can quickly determine the formula. After crossing down, reduce the subscripts when possible. Here we can see magnesium with its +2 charge and bromine with its -1 charge. When we cross the numbers down, we are just doing that. We are crossing the numbers, not the charges. As subscripts, these numbers are now going to represent the number of each atom. We are going to have 1 of the magnesiums and 2 of the bromines. This results in a formula of MgBr2, the exact same formula we would have gotten by making the Lewis dot diagram above. For our checkpoint questions, we are going to be writing out the formula for each of the ionic compounds below. After crossing the charges, we are going to reduce the subscripts anytime that is possible. And we want to remember that the subscripts are never going to have a positive or negative charge, since they simply represent the number of each atom. To start off with here, we have lithium oxide. Our lithium atom always has a +1 charge. Oxide refers to oxygen, which always has a -2 charge. The numbers are going to crisscross down to the subscripts for the opposing atom. That means that we are going to have 2 lithium atoms for every 1 oxygen, resulting in a formula of Li2O. In our next formula, we have titanium 4 iodide. Remember that because titanium has more than 1 potential charge, they must tell us which charge we are using. So our charge is a +4. It's important to note that this is not telling me how many titaniums there are. This is always going to be the charge. Iodide refers to iodine, which is a -1 charge. When these both crisscross down, I am going to end up with 1 titanium, Ti, and 4 iodine, I4. Next up we have sodium selenide. Sodium is an Na with a +1 charge. Selenide refers to selenium, which is Se with a -2 charge. When these two crisscross down, we end up with Na2, Se. Next we have aluminum sulfide. Aluminum always has a +3 charge. Sulfide means sulfur, which is a -2 charge. Our values are going to cross down. We are going to have 2 aluminum for every 3 sulfur, Al2S3. In our next example, we have vanadium 5 nitride. So vanadium with a +5 charge, again this is told to us because vanadium has more than 1 charge. In our other examples which did not include the parentheses, we were able to simply look at the periodic table because only 1 charge is ever possible. Our nitride is nitrogen, which has a -3 charge. We're going to crisscross each of those values down to have V3 and 5. Moving over to the right column, we now have radium chloride. Radium is Ra, and it has a +2 charge. Chloride is chlorine with a -1. After these crisscross down, we end up with RaCl2. Our next example is a little different, so I'm going to star this one. Beryllium is Be, and it has a +2 charge. Sulfur is S with a -2. Now when these values crisscross down, we end up with Be2S2. This is the first example that we've seen so far where we would actually need to reduce. Both of these values can be divided by 2, or, in this instance, simply canceled out. So my formula would be BeS. In our next example, we have calcium bromide. Calcium is a positive 2. Bromine is a negative 1. When they crisscross down, we have calcium, there's just 1, and bromine, there's 2. CaBr2. Our next example is very similar to the beryllium sulfide one. We have iron, this time with a positive 3 charge. They told us which one to use because iron has more than one possibility. Phosphide refers to phosphorus, and phosphorus is a -3. After I crisscross down, I'm going to have Fe3P3. This is another example where they will be reduced. So FeP would be my final formula. For our next example, we have cobalt. This is going to have a positive 3 charge, and selenium with a -2 charge. After the crisscrossing, we are going to have 2 cobalt and 3 selenium. This concludes Notes Part 4. When we come back in Part 5, we will be writing out the names and formulas for polyatomic ions.